So good evening, everyone. My name is Raquel Alonso Perez. I'm the curatrix of the Mineralogical and Geological Museum here at Harvard University. I'm delighted to welcome both our on-site and online audience for tonight's lecture sponsored by the Harvard Museum of Natural History. We are honored to have Dr. Salim Ali with us tonight to discuss his book, Soil to Foil, Aluminium and the Quest for Industrial Sustainability, published by Columbia University Press this year. Salim Ali is the Blue and Gold Distinguished Professor of Energy and the Environment at the University of Delaware, and a Senior Fellow at the Columbia University Center of Sustainable Investment. He is a member of the United Nations International Resource Panel and the Scientific and Technical Advisory Panel of the Global Environment Facility. Dr. Ali has received numerous awards, such as the Young Global Leader and the National Geographic Society Emerging Explorer Award. I met Salim in 2008 when he invited me to be part of the advisory board of the Gemstone and Sustainable Development Knowledge Hub, a grant-funded project by Tiffany and Co. to raise awareness on sustainable developments and conflicts related to mining of gemstones. Since then, I have been one of his main followers because he's such an avid writer, few books and hundreds of research publications in a very important research that I share with him, which is really focused on the societal and environmental impacts of mining and the role of governments and the international relationships between them. So with all that, please join me in welcome Dr. Salim Ali.
Greetings. Thank you so much, Raquel, for the generous introduction. It's wonderful to be back in Cambridge, Massachusetts. I have many fond memories of this area because I did my PhD just up the road at MIT. And in fact, this book has a particular connection to this area because I decided to dedicate this book to my mentor from MIT, Larry Susskind, who was my PhD advisor. And he is one of the reasons why I became so interested in complex systems issues, basically looking at the natural science aspects as well as the social science aspects of our relationship to materials. And through him, I was able to really focus on consensus building approaches, on how science can be used for conflict resolution. And so I dedicated this book to him, and it would have been great if he could have been here, but he's actually teaching an evening class today. So he told me that he's going to definitely watch the YouTube recording later. But the other connection also that I'd like to make is with actually this museum itself. One of my inspirations during my doctoral days was meetings that I had, two meetings I had with amazing intellectuals who had an association with Harvard and who have since passed away, Stephen Jay Gould and E.O. Wilson. And I had a chance to interview them one-on-one as a young PhD student who was working on this project we call Beyond the Ivory Tower, which was looking at how scientists should communicate to the general public. And of course, Gould and E.O. Wilson both were amazing at that. And so as this fledgling student, I got this opportunity to interact with them. And that inspired me to a large degree to write for the general public, but to do it with a certain level of depth, which wouldn't compromise the nuances which are important. And that's the real tension I've tried to grapple with in this book also, is to make sure that I am able to do justice to the topic. And that's one of the reasons why I went with a university press rather than a trade press, even though I knew it would not sell as much as if I had gone with a trade press, with a book agent and all that kind of stuff. So those of you who are aspiring author, that's another thing you might want to calibrate. Because I have gone through that route, and what I find is then that you are kind of forced to dumb down material. And it's very problematic in my view. I really adhere to that aphorism from Alexander Pope, a little learning is a dangerous thing, drink deep or taste not the Pyrean spring. Its shallow draughts intoxicate the brain, but drinking largely sobers us again. And so that's one of the reasons why this book, it's accessible, but some people will say, oh, it's a little bit too technical. And there's some things you just can't dumb down. And so, I hope that you will, take a plunge and read it and work through that. I've tried to make sure the language is accessible, but there will be some places which are a bit more challenging. So now, to start off, I have been heartened by the endorsements that I got. I mean, this book was, this is my fourth sole authored book, and I was really apprehensive about keeping this fine line about making sure that I am sympathetic to some of the concerns about extraction of non-renewable resources, but at the same time be pragmatic about how they are utilized in society. And so I was really heartened that when we sought endorsements, I got 2 endorsements from very different parts of the political spectrum. I got an endorsement from Bill McKibben, who's an environmental activist and writer, as many of you would know, at Middlebury College, a distinguished fellow there. We have a Middlebury alum in the audience. And, it's an author of best-selling books, The End of Nature and all. Many of you are familiar with his writings, and he's the founder of 350.org. But I also got an endorsement from someone from industry, the president and CEO of the International Council on Mining and Metals. And so that made me feel like, okay, maybe I did get it right. As an author, that's always your concern in terms of making sure the audience kind of is able to span a broader spectrum. So that's kind of the background to this book. The subtitle is interesting as well. I have used aluminum, and I'm going to use the American pronunciation. I will talk about why there are 2 pronunciations and spellings in a moment too. But I chose aluminum because as a parable, really. That using this element as a parable for our relationship to materials. And the reason why aluminum was very compelling is because it is used in the most wide array of products. And it's also a metal that has a very tortured history in terms of how humans have tried to extract it. And there are many paradoxes around aluminum that are fascinating. It's the most abundant metal in the Earth's crust, but it took us so long to extract it. And so why was that the case? And a lot of that goes back to sort of the physical reality of the metal. And going through that process, I would hope will also inform the general audience about that, the fundamental laws of nature which govern all of these issues. And so that's been also one of the reasons why I've really enjoyed writing this book, because my first degree was in chemistry, but then I moved more towards the social sciences. My master's in environmental studies and my PhD's in environmental planning. And so it allowed me to make the connections between the natural science roots of chemistry with the more applied reality of environmental planning. So what were the questions that motivated the book? Well, essentially these 3 questions, as a planner, I am very sort of solution oriented. Planners they're basically there to solve a problem, and they plan for a project and you try to deliver that project. So planners are in can-do kind of people. And now I'm the chair of a department of geography, and that's interesting because geography and planning are very much sister fields, but geography is much more about critically evaluating the past, and planning is much more about trying to figure out the future. And so this book has also been a good way for me to bridge geography and planning in that regard. So first question is around functionality and how these technologies that have become so essential for our lives, how have they come to be, and what is our relationship to the raw materials which make our society functional in that way. So that was one of the key questions. I was also very interested in what we call the material energy nexus, using the the story of aluminum to understand the material energy nexus, that when for any material there is embedded energy, and there is this kind of yin yang between matter and energy. And and if you go into, of course, fundamental physics, there's an essential connection between the two. And so how do we operationalize that material energy nexus? And how can we make more effective decisions about how much energy is needed to extract certain materials, and how we're able to track them through that process, and so on. And then the third question was about this notion of discoveries versus inventions. And this is connecting to, like, my earlier book. Before this book, I wrote a book called Earthly Order, which is, and the subtitle is How Natural Laws Define Human Life. And my argument in that book was that we have to move away from this notion of world order, which political scientists always use, right? Henry Kissinger wrote an 800-page book on world order, that we need to focus instead on earthly order, which is much more predicated in the laws of nature. And so connecting natural order to social, economic, and political order. But one of the arguments I made in Earthly Order was that earthly order can be discovered and invented. So you can go in and actually figure out the patterns in nature. But at the same time, it's not enough to just say that these patterns exist, but that human beings have agency to also invent order. And especially as we're now calling this current geological epoch, the Anthropocene, sort of the age of humans, very much that option for inventing order should be considered. And so how can we learn from the story of aluminum in that regard? So just to give you a preview in terms of the chapters and all, I've tried to, again, writing for a broad audience, divide it up into lots of sections. There are 4 parts. The first part goes back to sort of telling the story of the elements and how they came to be, and why aluminum has this particular place. Why is it the most abundant metal in the Earth's crust? So those are the kinds of questions I go into, and I'm going to give you some examples of vignettes in the presentation today, just to whet your appetite to hopefully read the full book. And then also this other big kind of puzzle, that aluminum, why was it a metal that was not metabolized by life? That also tells us a story about sort of those fundamental laws of nature that I was telling you about. Like, here is the metal which is so abundant in the Earth's crust, but evolution didn't lead to organisms that metabolize aluminum. We don't have any organisms that metabolize. And why is that the case? And that's another very interesting puzzle. So the second chapter is like, soil without soul, why aluminum was rejected by life. And I go through that process of understanding why there's the case. And then there's a whole separate story to it of why now, because of that, there are all these conspiracy theories about, the role of aluminum in our, deteriorating health, and why aluminum products and their commonplace usage has led to certain kinds of health ailments and so on. And some of that has, I shouldn't say perhaps glibly conspiracy theories, because some of there is some genuine science about concerns around it, but a lot of it has taken a life of its own around, people who have made it a kind of an activist cause to rally against anything which has aluminum. Don't cook in aluminum, don't use antiperspirants with aluminum, don't, you Google aluminum and health and you will have this miasma of material around, what's so bad about aluminum. Then the second part is around, how aluminum products, how we were able to harness aluminum and how the products started to become more commonplace, how we were able to discover the process by which this was possible. And there's a Harvard connection to that too, which I'll mention. Then the third part goes into how, the sudden discovery of the process by which we could extract aluminum economically led to this massive use of aluminum in military hardware, and certainly during the 2 world wars. And that has a lot to do with the properties of aluminum being so light as a metal and yet strong. And so it was an ideal metal for use in aircraft. And so that part of the book goes into, sort of this military-industrial complex aspect of aluminum, and also then how it became so used in household metal technologies of all kinds, and hence the title Soil to Foil, which is foil is probably the most bizarre use of a metal, where we use it to wrap sandwiches now, a metal which no one would have thought you would end up using metals to do that. And why that came about, there were some key people, the Reynolds family, and there's some amazing stories about how these inventions came about, the use of aluminum for so many different products. Then the fourth part is finally it goes more towards sustainability and how the relationship between aluminum and human beings and the uses of aluminum can be a good way for us to consider the pitfalls of developing more sustainable relations with metals. And so the last part really goes into some of the techniques in industrial ecology that have been developed to measure the impact of materials and life cycle analysis. And some of that part also goes into some public service roles I have. As Raquel mentioned, I serve on the International Resource Panel for the UN. And one of our roles is to try and help UN member states plan for resource security issues. So how can we use those methods to have more effective planning in this way? And then the epilogue of the book, it was being finished at a time when Russia had invaded Ukraine last year. And so the epilogue deals with also the geopolitics that is becoming so apparent with metals. And suddenly, aluminum became a big issue in terms of the Russians have a massive aluminum processing capacity and what that meant. And so the epilogue was like, there's always going to be surprises around metal sourcing, and this is what we should be thinking about in terms of long-term planning for metals. And one of the areas I end with is, and this is something I've been working also in terms of my academic writing, is mineral governance and how we should think about a global mechanism for managing mineral resources, which we do not have an international treaty on minerals, for example. What could be ways forward around that? So just some vignettes, and the book is, one of the authors who was inspiring for me in this book, writing this book, was Mark Kurlansky. Some of you would know his work on salt, of course, the famous book. He writes on one particular topic, like salt, cod, milk. But Kurlansky writes much more on the historical side, and not as much on the science side. Mine is a little bit more heavy on the science, but the history side is certainly, I try to make the connections. And this vignette is showing you how I try to make some of those connections, inspired by Kurlansky. So what's the connection here about these images? So you've got this snail, and anyone want to venture a guess in the audience just to make it more dynamic? What's the aluminum connection between these three images? But this is in the spirit of Kurlansky. So I know it's really hard to figure it out this way, but the word aluminum comes from alum. And before we actually discovered aluminum as a metal, alum was used for thousands of years as a component. Alum is it's a complex salt of aluminum, and it's been used in a variety of areas. But one of the most important uses of alum was as a mordant for dyeing textiles. And so here you've got, purple was a very special color because, purple was the color of royalty, and because it was so precious to have purple dyes. And purple dyes, the way they became so used across was through the alum mordant that was applied to these extracts from snails. And the snail that was used here in the Mediterranean, the city of Tyre, which is now in present-day Lebanon, became one of the key places where they would harvest these snails. And it would take up to 25,000 of these snails to get a teaspoon of the dye. And then you would need the mordant was really important. So you would mine the alum from places like this in the Aeolian Islands. There's an island called Vulcano in just off the coast of Sicily, which was one of the places where they mined alum. And Vulcano is where the word volcano comes from, incidentally, also. And that was then used by especially the Catholic Church, which at one point had a monopoly on alum mines as well. So there's this amazing connection between the, how this element was playing such an important role, even when we didn't know how to isolate it. We were mining it, we were combining it with biotic systems and producing textiles, which usually people don't associate textiles with mining, but here was a connection there. So I try to make these kinds of connections in the book, and there's several of these vignettes. And as with any other, non-fiction book for a general audience, very important to have character development. So I've tried to do character development also with individuals. So here, some of the key players like Sir Humphrey Davy, who was the guy who first tried to isolate aluminum metal, and he's credited with identifying that this is an element, because first people didn't really figure out, is there another element which is hiding in this alum somewhere, because the alum salts have sodium, there are other things, potassium, there are lots of other elements which go into them, but there was isolating the aluminum was there, and that's one of the reasons why apparently also that there are these two spellings. By one theory is, there are many theories of why you have aluminum and aluminium, is that earlier in his writings, Davy referred to this element which was he had not isolated as aluminum, and then later he coined the term was then, when it was later developed, was aluminium, and so that ended up, the confusion apparently happened that in one side of the Atlantic people started calling it aluminum. The other story, which is the one that actually is noted at Harvard in a display, which I will tell you about, which is walking distance from here, is that the first aluminium mining company, they misspelt it. And then they just dropped the I, and because of that, in America, which was the first aluminium mining company in America, was Alcoa. And so the first brochure dropped it accidentally, and the typo led to it becoming aluminum. So we don't know what happened. But those are very interesting stories. The other chap here in the second one is a man named Arthur Vining Davis, whom you may know because the foundation, and PBS is always saying they're supported by Arthur Vining Davis Foundation, and it's a big charity. He was the man who really transformed Alcoa and made it into this massive powerhouse. He was the second CEO of Alcoa, and I'll show you the first one, who has the Harvard connection, in a moment. Some other people here. These four individuals are the authors of a very famous paper, which basically gave us the understanding of how elements themselves form in stars, So the BFH2 paper you may be familiar with, that I tell the story of also going back to that paper and the BFH2, the Burbidge, Fred Hoyle, and I'm getting the last author who actually won a Nobel Prize in physics. The other two didn't. The others didn't because they started to basically reject the Big Bang theory, and they became big. Fred Hoyle was a big sort of skeptic of the Big Bang, even though he's the one who coined the term apparently on a BBC episode. But that whole story of how we consider elements individually, how they were formed, the geoscience history of the elements. So I also tell the story a bit of that, and the story of the Burbidges and how they worked together, and and it's a fascinating story also about how women are often neglected in the contributions they make in scientific discovery and so on. So I also allude to that. The other person here, the Mr. Aluminum, he's a guy who has been concerned about the health effects, and he calls himself Mr. Aluminum. Christopher Exley is his name, and he's kind of a toxicologist in the UK, but also, his whole story, his journey of how he became interested. One of his mentors who helped him get to this understanding was the only member of the fellow of the Royal Society who had no formal university education and yet was elected to the Royal Society. It's really interesting stories of these individuals. Fiona Solomon up there, who's a contemporary, currently she's the head of the Aluminium Stewardship Initiative, which is the aluminium industry's effort at promoting sustainability. So, those are some of the stories. And then this guy is really important, and there's the Harvard connection with him. This is Charles Hall, who, as an undergraduate student at Oberlin College in Ohio, discovered the process to extract aluminum from bauxite, essentially using a particular catalytic process with cryolite. It's an aluminum fluoride mineral, and then I talk about that. But the connection to Harvard is that he gave the money that established the Harvard Yenching Institute, because he was also very interested in China and East Asian studies. And even now, if you go to the Yenching Institute just down the road here, you go in the building, turn right, there's a picture of him, and there's a little bio, and it says, he was the founder of Alcoa. And his statue, which is made of aluminum in Oberlin College, is because, I don't know any of you Oberlin people here, but they keep decorating it with different things. It's like an icon in Oberlin College. And what I find really inspiring about his story is he did all this as an undergraduate student in a small liberal arts college in Ohio. You don't have to have a PhD to do discovery, and this guy was phenomenal, and, what he was able to achieve. And in parallel, there was a French guy, Heriot, also discovered the process, but Hall had a much better acumen for commercialization, thanks to his friend Arthur Vining Davis. So for our business school friends, it's also a story of how, if you don't have the business acumen, how both of them discovered it at the same time independently, but no one really knows much about what happened to Heriot. But, because of Davis and Hall's acumen for business, and also the kind of environment that Pittsburgh, Pennsylvania presented when they went there to develop their business, that they were able to make Alcoa, which is still around as a company. Right. The book also goes into a lot around the global aluminum cycle, how it's used. And, it's interesting to note that in this diagram that it's a metal which has been very well managed in terms of not that much. Still, it should be less, we would hope, but only about 22%, 23% is discarded. It eventually stays within the circular economy, so to speak, which is really great that it's able to have that. So I talk about why we can learn from aluminum in this regard. And a major reason for this is that material energy nexus, because it takes so much energy to extract aluminum that there is a good economic incentive to recycle it, much more so. And so that has led to processes around. And that's why you have, when aluminum was developed as a commercial product, a lot of the smelters were near hydropower locations. So in Quebec, for example, is a fascinating story of the town of Arvida. Arvida stands for Arthur Vining Davis. He wanted to make a town around his name, and this was like his utopian community. It was a smelting mining town north of Quebec. It's still there. It's worth visiting if you're interested. He made Arvida as this kind of a place which could be sustainable. That was his view. I mean, he really thought of it in those terms, in terms of circularity and so on. I also go into a personal narrative a little bit of how I became so interested in these kinds of issues. I'm originally from Pakistan, and I mention in the book how we used to have a guy come on a bicycle like this outside our house collecting recycling material, basically. And this is still, it happens in much of the developing world. We call, waste pickers, basically people who are part of the recycling economy. And then, this is the national soda drink in Pakistan, Pakola, which has all the three, the glass, the plastic, and the aluminum cans. So I talk about how you would measure, compare the impacts of that through LCA, life cycle analysis, and other vignettes. also the connection between health and aluminum and, the choices we make. Many times recyclability, even though it's difficult, we have to make a choice to have a non-recyclable product or one which is very difficult to recycle. And this is a classic case, Tetra Pak. So Tetra Pak, people know about as, we use these kind of long-lasting milk containers, or even your little apple juices you might send with your kids for their lunches. Those are Tetra Pak. And Tetra Pak was developed in Sweden. And aluminum is critical to Tetra Pak's effectiveness. There's a layer of aluminum in every Tetra Pak. And it has transformed the way in which dairy products, particularly milk, gets to people in the developing world, because you don't need refrigeration for it. So UHT milk in Tetra Pak being available to kids in the developing world. And yet it is very difficult to recycle Tetra Pak. But here's the trade-off, and so I go through the book in terms of, again, as a pragmatic approach, how do we go through that as well? I'm also connecting this to some of my own current research. And one project I have currently with the National Science Foundation is looking at redevelopment of old mining sites. Now, remember cryolite I mentioned to you? Cryolite was a fascinating mineral because there was only one mine in the world. And guess where that mine was? Anyone want to guess? Raquel would know where it was. No. Greenland. This is Iviktut in Greenland. It's the only place where cryolite was mined as a mineral. And this was such a strategic mine that during the World War period, the US built a military base. The Danes still have a military base there now, which was originally built by the Americans to protect this mine. And because it was needed, the aluminum was needed for the aircraft manufacturing. Now, thankfully, and this is another story of the invention of order or of minerals. Is right now most of the cryolite that's used is actually synthetically manufactured. So we no longer mine cryolite, and we have devised a process to synthetically make the fluoride salt that is cryolite in this form, and we use that now. But for so long, this mine, was the only source of cryolite. And it's a very rare mineral, actually. It's very difficult to find cryolite globally in this kind of reserve where you would be able to use it. So here, in Greenland, now we're doing a project with this NSF grant to look at the redevelopment of old mining sites and restoration ecology of these sites and how they can be used for, geoscience education, other kinds of efforts there. So I talk about the Greenland case also, and having recently spent time there. I also talk about, some of the work with the International Resource Panel that we've done with the United Nations, and that's the website for the Resource Panel if you're interested in the reports. One of the reports we've done in the panel is on remanufacturing. So it's not just, often we talk about recycling, but actually remanufacturing is a much better kind of outcome from a sustainability perspective. So I talk about ways in which that should be considered, the modularity aspects of how these kinds of material flow cascades happen before we move to recycling. And the ways in which this is being done now in the US is there is very positive development. There's a whole US Department of Commerce center in Rochester, New York, which is focused on remanufacturing and upscaling remanufacturing. It's called the Remade Institute. So I talk about, how these kinds of contemporary efforts are also underway that can help us move towards sustainability. Then the book finally goes into restoration from the point of view of biodiversity conservation efforts also, and looking at how we can have a circular economy that links to biotic systems. And one of the very promising areas, and this connects to some of my work in Australia, where I still have, I used to live in Australia 5 years. I'm also an Australian citizen, I should mention. And I directed a research center at the University of Queensland, which focused on mining and social responsibility. And so some of the work that's being done there is around what we call phytomining. And that's to use plants to extract metals selectively. There are these amazing plants called hyperaccumulators, which are able to take on metals, but aluminum is not one of the metals they're able to. But for other metals, we could do this. And so certainly for nickel, like in New Caledonia, you have these amazing trees which have green sap because they have so much nickel salt that they're able to absorb that the sap comes out green. And this is really frontier kind of work. If we can to commercialize it, probably for the rare earth elements, it would be really interesting to do because you need them in small amounts. You probably wouldn't be able to commercialize this for nickel because there are many other sources of nickel you need for higher volume. But that's the other thing I talk about is like, you have these boutique sectors. How do you figure out the cost benefit analysis for using certain technologies versus others? So, and then finally, just a coda to end with these two quotations. I use a lot of epigraphs in the book because I love, kind of anchoring the content and the wisdom of the ages, so to speak. And so, this is these two very different individuals to some degree. I'll just end with the epigraphs that I've used in two of the chapters. But Feynman really putting it in this context of a successful technology. What is it to be successful? Reality must take precedence over public relations, for nature cannot be fooled. And this is really the key that we have to get at right now. I'm putting that in there as a provocation now because a lot of the conversations around materials and especially metals is much more about how to frame the conversation around to please different audiences. There's a lot of anti-mining activism. There's a lot of activism around certain countries which have dominance over minerals. And ultimately, we have to go back to the geoscience reality of what we're dealing with. So that's really my goal with the book. So those of you who are interested, there's the coupon code if you want a discount from Columbia University Press. It's also going to be coming out as an audiobook if you're into audiobooks. But the audiobooks don't have the figures. So I personally say it's fine to have the audiobook, but I would say definitely having for this kind of book particularly, having the hard copy or the electronic version on a tablet is better for that reason that you actually get the images. So thank you. I'm happy to take questions. And I don't know if Raquel or Diane, are you going to moderate? Thank you.